Okay, so this is the challenge question from lecture 6. It's example 11, and I'm just going to go through the question and identify all the variables and then go through and solve it. So you as CFO are evaluating a capital investment. It requires an initial investment. I'm going to denote that I subscript O of $100 million. And it is expected to have a life of 10 years. So it'll be operational for 10 years, after which the capital can be salvaged for parts for $5 million. So salvage value is equal to $5 million. Over the 10 years of use, this investment will generate a 5% increase in revenues. So revenue increase equal to 5% and a 1% decline in cost. So costs are going to decrease by 1%. This year's revenues were $300 million and costs are 40% of revenue. Okay, so revenue is equal to $300 million and costs are equal to 40% of revenue. It will require an increase in working capital equal to $10 million at the beginning of the project, which will be recovered at the end. The capital will be located in a factory you own, which you pay annual mortgage payments of this with 20 years remaining. Now this is a little bit of a trick in that it's extra information because this is not incremental cash flows. You do not need to incorporate this into the analysis because it would occur whether or not you take the project on. So you estimate that cash flows associated with this project will be discounted at the company's cost of capital. So our required rate of return is going to be 10%. Now we are ignoring taxes in this problem, but of course we could look at taxes by taking after-tax cash flows, but we'll simplify that by just looking at just the values that we have here. So the question is, should we accept this project? Well, we're going to use NPV to evaluate. Okay, so I'm going to make a little line here. So those are all of our givens. So let's look at the first thing, not the first thing. Let's look at this revenue and cost business that we have going on here. So we have an increase in revenues. Revenues are going to increase by 5%. So we're going to have an incremental contribution to our revenues of $15 million per year. Every year, assuming that our revenues stay flat going forward, this is going to contribute $15 million a year. So we are, of course, assuming that revenues do not grow. Okay, and then we can look at cost. So we know that costs are going to decline by 1%. And we also know that revenues and cost have a relationship, such that they are 40% of revenues. Okay, so this is equivalent to the amount of the costs, and then we're expecting costs to decline by $1.2 million per year. Okay, so the net effect of the cost decrease and the revenue increase is going to be a positive $16.2 million. So it's going to have a positive effect on our cash flows. So it's going to increase cash flows by 16.2%. Okay, so that's the major calculation that we have to do. We can kind of start evaluating that net present value at this point. So I'm going to evaluate each of the cash flows at time 0, because that's what net present value has us do. And I'm going to denote any cash outflows with a negative and inflows with a positive. So, and I'm also going to evaluate everything in millions. Okay, so the investment requires an initial cash outlay of $100 million. So I'm going to put that in. It's at the beginning, so we already don't have to do any manipulation to it. So that's $100 million cash outflow. And then our annual cash flows, which we've calculated up here, that's going to occur for 10 years. So we're going to have 16.2 being the annual cash flow. Now I'm going to find the present value of that, and it's the same thing as looking at an annuity because it's going to be every year for 10 years the same amount. So that's going to be 1 minus 1.1, which is our cost of capital for 10 years. That's going to give us a positive effect of 99.54199. Okay, so what have we done here? We've taken care of the initial outlay. We have our revenue and costs taken care of. Let's look at working capital now. So we have an increase in working capital at the beginning of the project of 10 million. Okay, so we have to add to our working capital 10 million, which is going to be a cash outlay. But then at the end of the project, we recover it. That's at the end of the project, so that's 10 years from now. So I need to discount that back to time 0. And I'm going to recover it. So that's a cash inflow of about 3.85 million. Okay, so now we have taken care of our working capital. The only last piece we have is the salvage value of the initial investment. Okay, so again, it's similar to the working capital in that it's at the end of the project that 5 million is received from selling off the parts of the project. So 5 million, and I'll discount that at 10% for 10 years, and that's a cash inflow of 1.92771645. And that's all of the inflows and outflows all brought back to time 0. So all I have to do is add all of this together. And what I end up with is negative 4.67481, which tells us that because this is less than 0, our conclusion is do not accept this project. Okay, so this one kind of puts the questions we did in class a little bit on steroids because it brings into it a number of different cash flows. But the important piece here is you can do all of this stuff. You know all of the tools to be able to evaluate these things at time 0. The couple things to remember. Every one of these cash flows must be at time 0 to evaluate it. That's number one. The second thing is we only evaluate incremental cash flows due to the project, which is why I did not evaluate the 300 million in revenue. I only want to know how much revenue in addition to current revenue is brought in by this project. So very important that we look at only those change variables that are associated with taking this project on.